Hi, it's Rob. Welcome to the next video on the Infrastructure as Code on AWS with Terraform playlist, where we'll look at Terraform Cloud. Terraform Cloud is HashiCorp's managed service offering, which allows for provisioning of infrastructure in a remote environment optimized for the Terraform workflow. If you've been following along in the series or have exposure to Terraform, you know it's an infrastructure as code tool that lets you define and manage resources through human-readable configuration files. This provides for a consistent workflow over infrastructure lifecycles, regardless of the provider used to provision the resources. The Terraform Infrastructure as Code workflow lets you declaratively manage a variety of services and automate changes to them in a repeatable way. Terraform Cloud builds on these features by managing Terraform runs in a consistent and reliable environment instead of on your local development machine. It securely stores state and secret data, can connect with version control for collaboration, and provides a cloud UI with detailed views into your resources managed by Terraform. In Terraform Cloud, your resources are organized by workspaces, which contain your resource definitions, environment and input variables, and the state file. A Terraform operation occurs within a workspace, and Terraform uses a configuration and state for that workspace to modify your infrastructure. Terraform Cloud supports 3 workflows for your Terraform runs. The CLI workflow, which uses Terraform's standard CLI tools to execute runs in Terraform Cloud. The UI, or version control system driven workflow, in which changes pushed to a version control repository, such as GitHub, trigger runs in an associated workspace. And the API driven workflow, which allows you to create tooling or applications to interact with the Terraform Cloud API programmatically. To start out working with Terraform Cloud, we'll be using the VCS-driven workflow. But before we could do that, we need to create an account. When creating a Terraform Cloud account, you have 3 pricing options. You can create a free account, which provides open source features plus state management, remote operations, and a private module registry. There's the Team and Governance plan, which enhances the free account by adding team management, Sentinel policies as code, which can be used to enforce resource configuration policies, such as ensuring all taggable AWS resources contain tag definitions before being provisioned, as well as run tasks and additional concurrency. And the business plan, which provides drift detection, single sign-on, audit logs, and other enterprise-type features. We'll start out with a free account, then migrate over to the trial version of the Team and Governance plan later in this video to work with Sentinel policies. So to get started, I'll go ahead and click the Try for Free button, and then fill out the form to create an account. Then I'll open my email and click the confirmation link, and now I'm in my Terraform Cloud account. Now, to get started, I need to configure a workflow. So I'll select Start from Scratch, enter an organization name, and then create my organization. After creating the organization, I can now add a workspace. So for this demo, I'll use the version control workflow for my workspace, which will allow us to connect this workspace to a GitHub repository. So what I'm going to do now is jump over to my GitHub account and create a new repository for the demo. I'll give it a name of TF Cloud Demo Repo. It can be private, and I'll create the repository. Now I'll copy the link to clone it, jump into a terminal, and clone the repo locally. Now I'll jump into VS Code, create a main.tf file, and add some code to create an AWS EC2 instance. Now I'll go ahead and save the code, jump back over to the terminal, add the file, and push it up to the remote repo. Now if we jump back over to the repo and refresh, we see our main.tf file is added. So now we could jump back over to Terraform Cloud and connect to the repo. I'll give HashiCorp permission to connect to my GitHub repository. Looks like I need to enable pop-ups, so I'll go ahead and do it again. Then I'll select the repository I created for the demo. Then I'll select the repo, give the workspace a name, and then create the workspace. And now our workspace is created. So now if I click on the Projects and Workspaces link, we'll see our workspace listed, and if I click to enter it, we see that the configuration was uploaded successfully, and the next step is for us to add variables so that we can authenticate with AWS. Because if we jump back into the code, you'll recall that inside of the AWS provider block, we only added a region. So in our Terraform Cloud workspace, we need to add environment variables with the access key and secret access key for my IAM user. So from here, I'll click the Configure Variables button, then add a variable. I'll be using an environment variable for the AWS access key ID and save the variable, and then add another environment variable for the AWS secret access key, and I'll mark this as sensitive. Then save the variable. Now with the AWS access key and secret access key added, I can go over to Actions and start a new run. I'll keep the default of Plan and Apply and start my run. Now the plan's running. And with the plan finished, we see I have one resource to create, which is an AWS EC2 instance. Now it's asking me to review the following changes before continuing, which was one to create, and we're in apply pending status. So I'm going to go ahead and confirm and apply and confirm the plan. Now the apply is pending. Now it's queued. Now it's running. And now the apply is complete with one resource created. And if we jump into the AWS EC2 console and go into running instances, we see the one instance that we just created in Terraform Cloud. And jumping back into Terraform Cloud, we see a link to the state file which was created and is stored in Terraform Cloud. Okay, now that we were able to create a workspace, sync it with a GitHub repo, and execute a remote plan and apply in Terraform Cloud, let's move on and take a look at Sentinel policies. Sentinel is a policy as code framework integrated with HashiCorp enterprise products. It enables fine-grained logic-based decisions to validate your Terraform configuration files against policies which you define using the Sentinel policy language. In Terraform Cloud, policies are checked against your Terraform configuration when a run is performed, after the Terraform plan, but before an apply. Now, before we can use Sentinel, we need to upgrade our current Terraform Cloud account from the free version to the team and governance version. Now, this is normally a paid plan, but as you can see, there is a try for free option. Now, if I jump back in my Terraform Cloud account we see I have a free trial available for team and governance. So I'll go ahead and click upgrade. I'll change to the trial version of team and governance and then click start free trial. And now my free 30-day trial is active for one user. And now if I refresh the page, over on the left-hand side in the menu, we see I now have policies and policy set options. So I'll go ahead and click policy sets. I'll click to connect a new policy set. Then select the no VCS connection and give my policy set a name. Then for the scope of the policies, I'll select to enforce this policy on my Terraform Cloud demo repo workspace. So I'll select the workspace and then add workspace and then click the connect policy set button. Now with the policy set created, I'll go ahead and create a new Sentinel policy. So I'll click on policies, create a new policy. The type will be Sentinel, and I'll give the policy a name. I'll keep the default hard mandatory enforcement mode and then add my policy code, which will enforce tags on all EC2 instances. Then I'll select my policy set, add the policy set, and finally create the policy. Now, in order to test this policy, let's jump over to VS Code. And looking at this code, we'll recall that we currently have an EC2 instance created, which has no tags. So I'm going to go ahead and comment this out, save the file, and then push it up to GitHub to trigger a new plan, and then run and delete the EC2 instance. Now let's jump over into Terraform Cloud. We'll go into our workspace. And we see there's currently an update in planning mode with one resource to destroy. Now the plan is running, and we see the policy check failed with a hard failure. And this is because even though we're trying to delete the resource, the policy identified that it doesn't have any tags. So what we need to do now is jump back into VS Code and add a tag to our instance. Now I'll save the file, push it back up to GitHub, jump back over to Terraform Cloud. The plan is running with one resource to change. This time the policy check passed, so I'll go ahead and confirm and apply. The apply is queued and now running. And now that the apply is finished with one resource changed and the state file updated, let's jump back into the EC2 console. And now we see our EC2 instance has a name tag of web server. All right, so let's recap what we've done. We created a Terraform Cloud account and added an organization. Then we created a workspace and connected it to GitHub. The next thing we did was to add environment variables for the AWS access key and secret access key for our Terraform developer IAM user. Then started a new run to run a plan and apply with our Terraform configuration for an EC2 instance. After that, we moved on and upgraded our Terraform Cloud account so we could implement a Sentinel policy to ensure all EC2 instances will have tags, and then successfully tested the policy. Now, the last thing for us to do before we conclude the video is to delete the workspace. And we can do that by going into the workspace, then under Settings, selecting Destruction and Deletion. Before moving forward, please note the delete workspace warning and that this will destroy the state file. So it's strongly recommended you destroy all resources before deleting the workspace. Now, you can do this by either deleting the resource block from your configuration code, then pushing it to GitHub to execute the plan and apply before forcing the delete of the workspace, or you can go into AWS and manually delete the EC2 instance after deleting the workspace. But if you don't take either of these steps, your EC2 instance will remain running and you will get charged. But for the demo, I'll force delete from Terraform Cloud, enter the workspace name, and force the delete. So that concludes this video on Terraform Cloud. If you found it interesting, feel free to give it a like. And if you'd like to be notified when I add more videos, please consider subscribing to the channel. Thanks for watching.